So this is an overview of the problems I assigned for the weekend on Labor Day weekend. Hope you're having a good one. Nothing more fun than a Labor Day weekend doing some chemistry problems. So the problems I assigned were here. They were number 12C, and then on a couple other subsequent pages we'll get to. I assigned C because I didn't want to waste your time with A and B, but I might just talk to you about the approach real quick on those. Here you had moles of P4, so you would change moles to grams by using the mass of 4 atoms of phosphorus. So it'd be phosphorus has a mass of 31, so 31 times 4, and then you multiply by that number. So make sure you use dimensional analysis, moles and moles on the bottom and grams on top. If you wanted mass in grams of the stearic acid, you'd have this many molecules. You'd have to convert that to moles by using 6.02 times 10 to the 23rd, and then go to grams. So those are first year problems, pretty straightforward. So I want to make sure that I just talk to you briefly, but I thought you knew how to do those probably. So the next one's a little bit more challenging, but not too bad. You have this molecule, the C6H14 into O2. So C6H14, I'll go ahead and write that down and we'll toggle over to my paper. 14 into O2. And we have 3.03 moles of N. 3.03 moles of N. Now we'll toggle over. We want to know how many grams of this lysine. This is called lysine, so I'll just write that down. So that many grams of lysine, and by the way, lysine is one of the 20 amino acids that make up the proteins in your body. There are 20, and lysine's one of them. And they all hook together in chains to make protein. All right, so we have 3.03 moles of nitrogen. Now let's toggle over to the paper. Oops, that was the wrong thing. I want to toggle over to Zoom, which has a paper on it. Okay, so there's our lysine. It's a little blurry, maybe. Oh, here we go. Okay, so one mole of this contains 2 moles of nitrogen. We have 3.03 moles of nitrogen. So you could do it, there's a couple different ways you could do it, but 3.03 moles of nitrogen. And we're going to say, well, I know that there are 2 moles of nitrogen for every 1 mole of lysine. Because one of these contains 2 of those. Now you have moles of nitrogen. Now you know what I just did? It's still early on Saturday morning, so if you're sitting there thinking, wait, what are you doing? Do this. 3.03 moles of nitrogen. Where's moles of nitrogen supposed to go? It should be on the bottom. And the moles of lysine should be on top. Right? And then you have 1 mole of that is 2 moles of that. So it's the same relationship, but you do have to set it up in such a way so that the undesirable unit cancels. All right, and then you just keep going. You use the formula mass of that and change to grams. So that's all there is to that problem. I'll leave you to finish it out. There's a little talk through. Oh, another way you could have done that, you could have said that I know that I have 3.03 moles of N. You could have used a proportion. So 3.03 moles of N is to how many moles of lysine, so you call that X. And that would be equal to, you could say 2 moles of N over 1 mole of lysine. And there's 2 to 1, 2 of these for every 1 of these. 3.03 would be how many moles. That would tell you how many moles of this you had, which would put you in the same spot that you'd be in right there if you stopped and worked this out. Then you could go ahead and change to grams. So you could also think about proportions. Okay, so that was the first question. The second question, I had to go back to this page, and we're doing 31 was the next one. So 31, you have diethylene glycol, carbon, hydrogen, oxygen compound, and you want to find its empirical formula. Okay, so you know that the total of the carbon and the hydrogen and the oxygen will equal 100%. Therefore, if this is 45.2 and the hydrogen 45.27 and the hydrogen is 9.50, the oxygen we don't know because it doesn't tell us, but we know that has to add up to equal 100. So if you add that plus x, then you could solve for x. Now you know the three percentages, so you take your percentages and just change them straight to grams. And the reason you're doing that is because we're assuming that if we have 45.27% and they don't tell us how much we have, we just pick an easy number to work with. So pick 100, because 45.27% of 100, 45.27 grams. So you can just change percentages to grams and then change the moles and do the ratios like we did in class the other day. So I won't work that one all out because it's in the answer book, but that's a little bit of the logic that you would use. So you can find the percentage of oxygen by just subtracting from 100. Right, so that would be the approach for that one. And the next question we were supposed to do was 35. So we'll go over to 35. Okay, this one, you're looking, you know the compound contains this much carbon and that much hydrogen. And you use the same kind of approach on this one, but this one goes a step further. All right, so we have find your percentage of carbon, your percentage of hydrogen, change it to grams. So you'd have 94.34 grams of carbon. That's 94.34 grams of carbon, and you would have 5.66 grams of hydrogen. Okay. Then we're going to change that to moles. So click back here so you can see what I'm doing. So times 1 mole of carbon over 12 grams of carbon. I'm going to let's use 12.01. And hydrogen, 5.66 grams times 1 mole of hydrogen for every 1.008 grams. And these come off the periodic table, which I didn't pull up, but you guys all have that. So we'll do our quick calculator here. And we know that we have 94.34 divided by 12.01, 7.86. And 5.66 divided by 1.008, 5.62. You divide both of them by the smallest, so that's going to be divided by 5.62. All right, so 7.86 divided by 5.62. And we're looking at 1.4. So 1.4 to 1. So 94.34. Just double checking my math. 1.86. All right, so you see 1.4 and 1. My mind went blank there for a minute. Okay, so if we said, usually these work out a little better while I'm hesitating a little bit. That's right. Oops. $1.398 I decided that's close enough to a third to call it a third. So it's closer to a third than it is to a half. So let's try multiplying that by 3. We get 4.2, 5.62 divided by 1. Actually, I'm going to avoid this video getting long. I'm going to stop it here. I'll come back with the next video. Otherwise, it get too long. So this is going to be part 12C and 31, and we'll come back to this in just a minute.